I think the key on problem number 6 is to draw a picture. I want to find the length of r to s if s is between r and t. So here's r, here's t, s is someplace in between them. And I'm told at r to s is 1/3 the length of r to t. In other words, this is 1/3, which will make st 2/3, right? And we're also told r to s is 3x minus 3. And we're told s to t is 2x plus 6. Now, I could do this in a couple different ways, but I think I'm going to use my fractions here. Notice s to t is twice as big as r to s. So if I take 2 times rs, that will equal to st. So if I take 2 times 3x minus 3, I'll get 2x plus 6. Well, let's solve for x. So distribute, we get 6x minus 6 equals 2x plus 6. And then let's get all the variables on one side, so we'll minus 2x from both sides. And at the same, I put in x there by accident, sorry about that. And at the same time, let's add 6 to both sides. So in other words, 4x equals 12, or x equals 3. I'm not supposed to, I need to find x, but I'm not done. The question says find r to s. So in other words, r to s is going to be 3 times 3 minus 3. 3 times 3 is 9, minus 3 would give us 6 for our answer. If we take a look at number 7, I think we're kind of do this same way. I want to find the value of y. If AC equals 3y plus 5, CB equals 4y minus 1, and AB equals 9y minus 12. And I know C is between A and B, so I'm going to do that here. So here's A, here's B. I know C is someplace in between them. I don't know where, but now I know A to C is 3y plus 5. I know C to B is 4y minus 1. And I'm told A to B is 9y minus 12. So we're just going to use our segment addition problem on this one. And I'm going to say 3y, I'm going to say actually AC plus CB equals A to B. Or substitute it in there, we get 3y plus 5 plus, I switched pens here and it's still not working, 9y minus 12 equals, whoops, that's not right. My pen was trying to help me out there. Plus 4y minus 1, because that's CB, equals 9y minus 12. Now, if I combine my like terms, 3y plus 4y is 7y. And then if we do 5 minus 1 is 4, so plus 4 equals 9y minus 12. We'll do the same thing we did in the previous problem. I want to get all my y's on the same side, so I think I'll subtract 7y. I always like to move the smaller one. And at the same time, let's add 12 to both sides. So then I end up with 16 equals 2y. Divide both sides by 2. Y equals 8. And I just noticed the answer got typed in there. My font didn't work. That should be 2 times the square root of 5. Now I want to find a to b. Since it's on the grid, remember a to b just means the distance from a to b. So then we're going to use my right triangle here. If I count from A to B, there is 1, 2, 3, 4. And then I go up 1, 2. So in other words, if I use Pythagorean theorem, c squared equals a squared plus b squared, or c squared equals 4 squared plus 2 squared. C squared would be 16 plus 4. C squared is 20. I don't want it as a, oh, back it up here. C would be the square root of 20, but I got to simplify that. And I go, what goes into 20? And that would be 4 and 5. The square root of 4 is 2 times the square root of 5. And if I want to find, if AB is my hypotenuse, I want to find the area of my triangle. Well, the area of my triangle is 1/2 base times height. So I'll take 1/2 times 4 times 2. Notice my 2 is reduced. My area is 4. There were no units in that problem, so we can just leave it just like it is.